Hi everyone, today I'm going to take you through some of the more complicated angle problems. Before I do, can you complete this starter please? Come back on for the answers. So, question 1 here, we would like to solve the equation. We have to start by taking away 4 from both sides, leaving 3x equals -6. Divide both sides then by 3, and we are left with x equals -2. Next question here is to find the missing side. Now, we need to use Pythagoras' theorem, which requires us to label our sides A, B and C. You might have thought of using SOHCAHTOA since we have a right angled triangle, but unless we have an angle, then we can't use SOHCAHTOA to find a side. So it has to be Pythagoras. Now, the formula for Pythagoras' theorem is c squared equals a squared plus b squared, as long as c is the longest side. The longest side is always across from the right angle, so that's how we can find out where to mark on as c. So, substituting in here, we have 20 squared equals a squared, which we don't know what that side is yet, plus b squared, which is 13 squared. Since we're trying to find a smaller side, we have to rearrange this slightly. 20 squared take away 13 squared then can go into our calculator. And we end up with a number of 231. If you're using your phone calculator, you will need to square these numbers separately and then subtract them. The last thing we always have to do is to square root the value for a squared. That will give us the value for a. So 15.2 metres will be our final answer. And that's to 1 decimal place. Right, so the mixed angle problems are going to include problems of straight lines, of parallel lines, and of triangles, all in the one huge diagram. Okay, so this first diagram here, I want to fill in all of the missing angles. So the first thing that we might notice is that we've got some parallel lines, and I'm going to create F shapes. So I'm looking for F's and Z's whenever I've got parallel lines. So the first angle I can fill in, well, the 2 dots there are the angles contained within the F. Therefore, 34 degrees can be put into that space there. Now, if I get rid of those red lines now, additionally, we have got then a straight line along here, which includes the angle 34 and the one above it, which means that the angle in here above the 34 can be got by doing 180, take away 34. Okay, remember 180 forms a whole straight line, therefore if we take away what we have from 180, we can get what's left over. So at the top there is 146. The next thing we'll need is the angle here underneath 102. Again, it forms a straight line with 102, so we can take 102 away from 180 to get that angle of 78. Now again, if I use these 2 parallel lines with the line on the right hand side, I've got an F shape. The 78 is in the F with the shape at the top right, which means the top right angle is also 78. And lastly, last but not least, I can find out the bottom of this triangle. Now the triangle here is the bottom section of the diagram. So I can take that as 180, take away the two angles inside the triangle, which are 34 and 78, which will give me 68 down the bottom. Okay. Now additionally, you might notice as well that if we were to use the whole triangle here, so if we were to use this large section around the outside, we've got the angles 34 and 78 plus the angle 68 will add up to the whole triangle. So if we ignore the middle section, we also have that those 2 angles up top will add in the triangle, the larger triangle, to give us the 68 down the bottom as well. Okay, So the angles 78, 78, 34, 34, they have to be the same within the large triangle and within the smaller triangle as well. Okay, a slightly different diagram here. In this case, I can't really spot any F shapes. Maybe we could actually if we were to extend some of the lines, but mostly I can spot some Zs. So there is a Z here represented by the red lines. Yes, it's backwards, but it's still a Z shape in quotation marks. The two angles contained within the Z are 48, which means down here has to be 48 as well. I can also spot a Z angle going in the other direction here with the 73. Now the other angle up top there is contained within the Z with the 73, so it has to also be 73. Now, lastly, I've got a few angles to calculate here, okay? The first one I need to do is that one down there, and that green angle forms a triangle with both the 48 and the 73. So I could do 180, take 48, take 73. Okay, that will give me the green angle down the bottom. Also notice that down the bottom we have a straight angle going all the way along here, and that includes the angle 48 and 73. And if I was to take the full straight angle, I could take the 48 and the 73 away from 180 using that condition as well to find out that the bottom angle has to be 59 degrees. Now the angles up the top, we have got a straight line here with the 73, so 180 take 73 will give us 107 on the right hand side, and 180 take 48 on the left will give us 132 degrees. Again, there's two angles there that form the straight line up the top, which is why we can take those singularly away from 180. Okay, one more example. Now in this case I'm going to try and use opposite angles as well as some straight lines and as well as some Zs. Okay, so the first thing that I am going to fill in is the one across from the 100, 110. So they two are opposite. If we were to form an X shape with those two lines, we can see that 110 would be on the left hand side of the diagram. So that's 110 there. Additionally, I've got also some Z shapes to come in here as well, and I've also got another couple of opposite angles. So the next opposite angle I could spot is using those two lines. So I'm not using that larger line going through, I'm just using the ones that I've put over with blue. Opposite the 40 will be up on the right hand side, so up here will be 40 degrees. Okay, now from here I could spot a Z shape in there. Now this is probably one of the most complicated diagrams we'll see, alright? This isn't a simple diagram by any means. But this one up the top right, the very top right, has to be 40 degrees since it's in the Z with the other 40. Then I have got triangle down the right hand side, so 180 take 110 take 40 will give me the bottom angle. All those had to add up to 180. So that'll be 30 down the bottom there. And we'll get rid of the red lines again. The only thing left to find then is the other two angles that are opposite one another. The way I'm going to start to find these, let's use a different colour, is by considering that large purple angle that I have written in there. This is a straight line here, which includes the angle 110, the missing angle, and the 40. If I take both of those away from 180, since a straight line adds up to 180, then I will get 30 as my angle in that gap there. And then eventually we can take those two lines as a cross to say that the 30 is opposite the angle next to the 40 up the top. So that angle next to the 40 up the top has to also be 30 degrees. Okay, now some of these angles aren't exactly at the point, that's just because I don't quite have enough space to fit them in. Okay, so that's the extent to what we'll be doing today. You will see various different diagrams, but what you're trying to spot are triangles particularly, and F's and Z shapes. You will also need sometimes straight lines and sometimes opposite angles. So it's mixed because it's everything we've done, all the tricky angle identifications in basically the one diagram. Okay, I'll give you all the information you need on the Teams page. Please let me know if you need any help, and come back on, just let me know how you're getting on. Okay, good luck with these.